It's a question based on functions. Fine. What's given here? The function f maps the set of all natural numbers to whole numbers such that f of x into y is fx into fy plus fx plus fy for all x and y. And fp is equal to 1 for every prime number p. What does it mean? If your input is prime, then the output will always be 1. It does not matter the value. It should be prime only. That means f of 2 should be prime, f of 3 is prime, f of 5 is prime, and so on. But actually, this 16,000 is not prime. So what's the value of f of 16,000? Okay, let's try to use this concept here. F of p is 1. I'm looking for f of 1600. This f of 1600 can be written as 16 into, sorry, it's 1,60,000. Can we write it like this? Yes or no? And the 16 contains 4 twos. This can be written as how much? This is 5. This is 10,000. This is actually 10,000. When you try to split it, you get two fours from here also. Sorry, four twos from here, and this can be written as 625. That is 5 to the power 4 also. So effectively, you get f into f of 2 to the power 8 into 5 to the power 4. So let's try to calculate first f of 2 and f of 5. Now we know that if p is a prime number, f of 2 will be equal to how much? It will be 1. But I'm not looking for f of 2, I'm looking for what? 2 to the power 8. Let's try to calculate f of 2 square. That is 4. F of 2 square. If you try to use this equation, let's assume that x and y both are 2. So f of 2 into 2 is f of 2 plus, sorry, into f of 2 plus f of 2 plus f of 2. What do we get from it? F of 2 was 1. So 1 into 1 plus 1 plus 1. This gives you how much? 1 into 1 plus 1 plus 1. All the values are what? They're positive. So 1 into 1, this is 1 into 1 plus 1 gives you 3. Similar fashion, if you try to calculate f of 8, it can be written as f of 4 into 2. So you get f of 4 into f of 2 plus f of 4 plus f of 2. This comes out to be, this is 3 into f of 2 was 1 plus 3 plus 1. So you get 3 plus 3 plus 1. That is equal to 7. Now can we try to write this 3 as 2 square minus 1? This 7 as 2 cube minus 1. And look at this. This is 2, which is prime. Let's try to generalize it first. Can we say if the input is f of p is a prime number, p to the power n. If the input is p to the power n, then the output is always p to the power n minus 1. Because for an input of 4, my answer is 3. For an input of 8, my answer is what? It's 7. Can we generalize it? If you want to cross check it for 5 also, we get the same result. So using that logic, what I can say, f of 2 to the power 8 must be equal to what? 2 to the power 8 minus 1. Yes or no? Now, it matters that what is p here? It was 2. Let's see what happens if the value of p changes to 5. F of 5 should be equal to 1. When you try to calculate f of 5 squares using the similar logic, you won't get it 5 square minus 1 here. You'll not get 5 square minus 1. You'll still get 2 square minus 1. That is 3. Yes or no? So what does it mean? If you want to generalize it, f of p to the power n, if p is a prime, then the answer will always be of this type, 2 to the power n minus 1. 2 to the power n minus 1. So f of 2 to the power 8 should be 2 to the power 8 minus 1, and f of 5 to the power 4 should be equal to what? It should be 2 to the power 4 minus 1. Yes or no? So what do we get here? 5 to the power 4 is 2 to the power 4 minus 1, and f of 2 to the power 8 will be 2 to the power 8, that is 256 minus 1, 255. And f of this 5 to the power 4 will be equal to 50. Now let's try to calculate this one using this formula. F of x into y is f of x, which is 2 to the power 8, into f of 5 to the power 4 plus f of 2 to the power 8 plus f of 5 to the power 4. What is f of 2 to the power 8? It's 255. F of 5 to the power 4 should be 15. F of 2 to the power 8, that is 255. And 5 to the power 4 is again 50. So now you're left with what? 255 into 15 plus 255 plus 2 plus 15. When you solve this, you get the sum as 4095. The correct answer has to be second option.